everyone, and welcome to the next instalment of CODA's webinar series. My name's Shaun Sadler. I'm the General Manager here at CODA, and today we're going to be taking a closer look at proactive hazard identification in offshore decommissioning with CODA partner Vanguard Solutions. Now, the effective management of risk is obviously a critical path activity in all parts of the oil and gas industry. Decommissioning, however, involves such a wide range of potentially hazardous activities that there's a need to be particularly versatile and innovative in our approach to risk management. To talk more about this, I'm delighted to welcome our speaker today, Dr. Martin Bardsley, a Technical Director at Vanguard Solutions, who will help us build understanding of the role of HAZID processes in offshore decommissioning, as well as looking at some case studies and concepts of future-focused risk management. As always, please don't forget to drop your questions into the chat and Q&A windows on Teams as we go along. But now that's enough from me. Martin, it's over to you.
Okay, as they said, my name is Martin Bardsley. I'm the Technical Director for Vanguard Solutions, and I've worked in the offshore industry and onshore LNG and other systems for 25 years plus. We're going to be talking about hazard and offshore decommissioning and lessons learned from accidents and near misses. So I'm going to go through this slide. Now, some of the slides have been recorded and they're timed, so just bear with me. So offshore decommissioning is and the role of HAZOPs. Offshore decommissioning is basically a very complicated process of retiring oil and gas assets involving well plugging, pipeline abandonments, platform removal, and site cleanup. It often involves high-risk activities, sometimes heavy lifting, cutting, diving, often in harsh environments. So hazard identification is important, and we're just talking about the HAZID process at the moment. It's a systematic early stage risk assessment to identify potential hazards and failure scenarios before and during commissioning. It also brings together multidisciplinary teams and basically is a way of getting experts to brainstorm what could go wrong and basically how to prevent it. It is important that we emphasize that this is a early stage, late stage, and throughout the lifetime that you actually involved in risk assessment and multidiscipline. So some critical important factors, sorry I'm having trouble with the slides, is basically an effective HAZOP ensures appropriate controls are in place. So HAZOP is important to get the engineering procedural controls in place. Basically you list them and understand them, and it's aiming to prevent the accidents and environmental harm. One thing to emphasize is decommissioning is not a routine operation, especially in the offshore Australia environment. And with deteriorating infrastructure, there are some hazards that are basically hard to identify. We need to identify these and get the key safety barriers. So in this actual presentation, we'll basically be looking at some case studies where some specific decommissioning accidents happened. So I'll go on to the next slide. So just to give you a scale or an understanding of the offshore decommissioning issues, and it's probably been said many times, it's basically vast in scope. Hundreds of offshore structures and thousands of wells worldwide are due to be decommissioned in the North Sea, Gulf of Mexico, Asia Pacific, and Australia. Basically, this dismantling of the Australian is forecast to be over 50 billion in the coming decades. So that's to do with plugging wells and removing the offshore equipment. So there's challenging conditions. Decommission is often deals with corroded, unstable, or excuse me, or marine growth covering the structures. These can be basically add more complexity to the job than a new build and adds more uncertainty. So industrial expert note decommissioning can be more dangerous than initial construction since structures physical condition is poor and companies may be tempted to cut costs due to its non-revenue work. And so we'll talk a bit about that later. But complex operations, so with each type of facility, the fixed platform and the floating platform or floating production units, they present unique hazards, such as heavy lifts, crane operations, underwater cutting, sometimes explosives, well plugging and abandonment, and the waste handling. So this is a multifaceted sequence of operations. So for decommission, hazard visibility may not be completely visible. They're less obvious than those in regular operations. If you think about it, during regular operations, you've been doing things day in, day out. But with decommissioning, you basically, it's sometimes, even for the company, it's a one-time operation. So there might be complexities that are not visible, and you need to rigorously identify them during the hazard identification stage. So I'll go to the next slide. So why hazard identification? And I talked about this at the start a tiny bit, but it's a structured brainstorming activity. A hazard typically occurs early in the decommissioning plans, and basically it's a systematic breakdown of the project, whatever it is. It identifies the hazards for each step. It's a common technique, so everybody uses, often includes checklists, what-if analysis, and past incident reviews, and also guide words and other techniques. Most importantly, it's multidisciplinary. If you don't have the right people in the room at the time, or they're not engaged with the process, then you don't get the right outcome. So it's important to have the right people involved. And so I often think having senior people involved, or people that know what they're talking about, so that it's identified. So the output is a hazard register. That's a formal output, and this results in a comprehensive list of some of identified hazards, their possible consequences, recommended safeguards, and mitigation measures. So these could be, you know, what extra support you need, special lifting tools you need, and permit to work systems. So those will be identified, and it's a register where these sit. So, you know, a hazard shouldn't be a one-time outcome. It should be used throughout the process. It's not it's a dynamic result. So the hazard register should be taken forward and looked at every stage in operations and revisited and refined as the project goes forward. It's one of the basically tools that should go into the job safety assessment and other issues. Let me just go back to that previous slide. Okay, and so this is an important issue, is it is actually there for us to understand what is happening and how we're preventing it from happening. Also, just as a general comment, is that it also helps out with understanding the job. If in the hazard, you're just talking through the whole job, and so it gives everybody a key focus for understanding the job. And one important thing is that keeping people continuity as well. You know, having people that are going through the hazard and doing the actual job is important in my view. I'll go to the next slide now. So some political perspectives that have come apart out of this. So basically, UK and Norway have basically been getting stricter in their regulations. So they demand comprehensive risk reviews and basically a lot of demonstrations for decommissioning. The Gulf of Mexico, they were relaxed at the start, but now they're getting more involved. They're being prescriptive and getting safety alert. While NOPSEMA, the Australian regulatory body, are developing stringent guidelines as decommissioning ramps up. So the message is all regulators are basically getting more stringent, especially about decommissioning. And they're looking at, as have been stung in the past, looking at basically sharing messaging and enforceability as well. So there's been strong regulation oversight, and now we see some penalties that are happening. We had an example in 2019 where I'm going to talk about this in the case studies, where basically the contractor was fined $4 million under a health and safety law. So they're starting to use actually some legislation. So industrial pressures in oil and gas are seeking to reduce decommissioning costs, sometimes push back on new regulations or levies. So this is also happening in the industry. There is some ongoing debate between ensuring rigorous safety and environmental protection and financial burden of regulation. So that's some interesting points to come over. But the stakeholder scrutiny is also increasing. We're getting more workforce involvement, more political involvement from the public, and less tolerance for safety lapses. If you do something, you'll be in the news. And also unions and safety advocates are calling for stricter enforcers of when we have a near miss. So it's not just if we have an accident, if we have a near miss is often called into state and you'll be held responsible for that. So HAZID can help with all these issues, identifying before. Okay, I'll go to the next slide. So I'm going to go actually talk through the case studies. And now I actually recorded this bit just to try and get so my mouth moved through these case studies because I wanted to be fairly succinct. Okay, so let's go through the first case study of what happened. So what was being done? Basically, a dismantling crew in the UK were taking apart a jacket, the steel lattice legs that once held up an offshore gas platform. The work was taking place onshore. The critical task was 2 workers were cutting off the skirt pile, a huge steel pipe that anchors a jacket to the seabed. The piece weighed about 27 tons, roughly the weight of 18 cars. So what went wrong? After the cut, the skirt pile suddenly broke free. It swung or dropped into the basket of the 2 men's cherry picker and threw them to the ground. So what was the human cost? 1 worker died, the other suffered from life-changing injuries. So why did this happen? The investigators found that the company had not treated skirt pile removal as a serious hazard. So no dedicated plans, no engineering support or crane ready to take the load. This task had been labelled low risk, so no one asked, what if this piece falls? So if we go through what the legal consequences were, the company was prosecuted under the Health and Safety Work Act and was fined £3 million. So key lessons that they learned or can be learned from this: decommissioning is risky as construction. Plan it with the same discipline. Never assume low risk without analysis. Heavy cuts demand a hazard study, control of the energies, using support frames, cranes, or cutting heavy items into smaller sections before they can move. If you imagine it can fall, plan for it. In short, the danger isn't over when the structure comes ashore. Good planning and proper support could have prevented this tragedy. So let's go on to the next one. So let's go through this case study. Where and what? This was in the Gulf of Mexico during a flooding and abandonment work to seal an old well. A portable drilling unit called a power swivel was being removed from the well at about 3:30 a.m. right after a shift change. How the hazard appeared. Pulling out the power swivel left a large gap in the grating deck, an unguarded hole where the well had been. The lift, the crane hoisted the heavy swivel, roundabout guided it with 3 tag lines, forcing him to stand close to the load and right next to the open hole. So what was the accident? The load moved, the worker slipped or was pulled off balance and fell 30 feet through the hole. He was killed. So why did this happen? The hole was neither covered nor railed off. No one wore full protective gear. The pre-job safety talk skipped the open hole hazard, and not everybody, including the victim, attended. They reused an old JSA and never updated for this specific task. Short taglines kept the rig in a danger zone. Okay, so what was the regulator's response? This is from a safety alert. Guard every hole with covers or railing. Wear a harness whenever there is a chance of falling. Brief the whole crew after a shift handover. Plan better lifts using long taglines and assign dedicated lift supervisors. So what were the lessons that they learned for the hazard? is that decommissioning plans must ask, will removing this gear create a hole, and how will we control it? So formal risk reviews are only the start. Crews must update hazards on the spot as conditions change. No damage is too obvious to write it down. If it isn't documented or controlled, this is an important part, treat it as unseen. So the bottom line is an uncovered hole and a lax safety discipline cost of life. So vigilance, proper barriers, fall protection and clear communications are non-negotiable aspects. So the next case study, the job, crews were cutting up an O pipeline. They thought it was safe because it had been flushed with water and saw clear water at the few valves. So what was the hidden dangers there? Pipelines have high and low spots. Gas can be trapped itself in dead legs that flushing water never reaches. Seeing clear water in one place does not prove the whole line is gas-free. So what happened in this incident? First cut was the low point. Nothing happened, giving the team a false sense of confidence. The second cut was in a higher section where trapped methane met the torch flame. A flash fire burnt a worker's face. It could easily have been fatal. Okay, so the investigation found that residue gas hazards were barely mentioned in the paperwork. No plan for multiple purges, pipes, or continual gas monitoring. No lower explosive limit tests right before the hot cut. Believing one flush made the line safe, that was a core mistake. Skipping gas testing and continuum monitoring was another mistake. Failing to involve process safety experts in the risk review. So what were the key lessons learned by this? Assume gas pockets exist unless proven otherwise. Purge from several points, inerting if needed, and retest and test again before every hot cut. Document the hazard in the job safety analysis and clear steps to eliminate it. Bring in people who understand how fluids behave, not just the cutting crew. So the bottom line is a simple low flammability check or extra plugs could have avoided this flash fire. Treat every decommissioning cut as if flammable gas might still be inside and build your plans around proving it isn't. Okay. So the next case, where and what happened? Offshore Australia during removal of a tiny Simbad platform. It had only one support leg, a monopod, so once the leg was cut, the whole top side had nothing left to rest on. The lift-up setup, a crane held the top side while the workers cut through the single leg. The crane auto-tension system kept a slight upward pull on the load to offset the vessel motion. What was a near miss? Before the cut was finished, the upward force snapped the remaining steel. The topside twisted and swung like a pendulum over two workers standing on the caisson. The crane operator reacted instantly. He swung the load clear, then lowered it into the sea to stop the swinging. So no one was hit, but it was inches away from a double fatality. So now we're going into why did it happen. Lift plans did not account for the extra force from the auto-tensioning or the risk of early rotation. Planners relied on were always done it this way instead of fresh analysis for one leg platform. Workers were allowed beneath a partial cut, with an unstable load. What the investigation highlighted: every decommissioning lift needs a specific hazard that asks, what if this piece shifts, before we're ready? Possible mitigations they missed: stop-start cut so the leg remains locked until the steam is ready for final separation, remote or robotic cutting to keep people off the structure, extra temporary supports or slings to stop rotation, clear rule, no person under or on a load being separated. So what was the regulatory takeaway from this? It was in a worst safety bulletin. Calculated all forces included automatic crane functions, design platforms with future removal in mind, treat near misses as serious as accidents, they expose real gaps. So the key lessons were: small structures can hide big risks, single leg designs need specific lift plans and specialized. Never rely solely on the past experience. Create a fresh hazard review for each asset. Keep people out from under suspended or partially severed loads. Plan the cut sequence so you control the timing, not the steel. So the bottom line is that the crew avoided tragedy only through quick action. Proper hazard analysis and stricter exclusion zones will remove the luck factor altogether. So this is the last case study. So what was being done? Workers were disconnecting an own floating storage unit off Libya so it could be towed away. How the FPOs hold in place? They sit like ships but are kept on site by heavy mooring chains connected to risers and flow lines. All these lines must be released before towing. So what was the accident? One mooring chain snapped without warning. Broken chain whipped across the deck, throwing 3 people overboard, all who died. A 4th worker went missing, presumably dead. Another was injured. So 4 lives were lost in seconds. The probable gaps in the risk control: chains may have been heavily corroded or still under tension during cutting. The area was not cleared of people and they were in the danger zone. Contractors may not have done a full hazard review. Supervision and communication were likely very weak. So what a good hazard should have asked: what if the mooring line fails suddenly? How do we keep everybody out of the snap back zone? Do we need backup securing lines or remote tools? Has every chain and shackle been inspected for wear and corrosion? So from this, some key lessons learned were: treating mooring and towing work as high energy, high risk tasks. Detention gradually and add redundancy before cutting or underpinning anything. So we need to enforce exclusion zones. No one should stand where a chain or wire could strike. Apply the same rigorous hazardous standards to marine operations as to cutting steel. Also ensure all crew, especially third-party contractors, share a clear plan and a common language for work. So from this, the bottom line is: mooring chains store massive energy unless crews anticipate a sudden failure and stay clear. A single snap can be fatal. Through planning equipment checks and stringent no-go areas can save lives. Right. So thank you for listening to those case studies. And it's an interesting perspective that if we disseminate this information, we learn from the lessons of these incidents. So this is the kind of best practice we want with hazard studies. And so what's happening now is that lessons are being learned from these incidents. So we're getting case studies from the North Sea, Gulf of Mexico, Australia and beyond. And so we have industry organizations that are bringing those together, and they're actively sharing safety alerts and lessons learned. So some mistakes, the mistakes aren't forgotten about, and that we can understand them, especially when we're in a hazard, so people know what possibly could happen. So various regulatory bodies have been publishing guidelines to ensure that we have better testing. best practice during decommissioning. The UK is providing guidance on decommissioning and dismantling in the offshore. So is Australia, and we're also getting updates of near misses as well. So we're looking at the way forward. We're looking for best practice to consider decommissioning in the design phase of new facilities, increasing engineering about how would we eventually remove this if we're abandoning this safely, and how we might design for this. So NOTSEMA has started that planning for decommissioning, start early and become more detailed as the assets near the end of their life. So to the next slide. Okay, so this is an international perspective and also best practice. So we're looking to enhance the HAZOP process. Okay, I think I've just, so enhance the HAZOP process. Best practice in operators by conducting multiple hazard identification exercises with an initial hazard during engineering, like feed engineering or initial engineering, scoping it out, and then detailed design HAZOP and HAZID, and closer to execution as well. So also involved independent facilitators to give a fresh pair of eyes, cross-discipline workshops, so everybody's involved. So it's also important to get the culture of safety right. So we need a strong culture of safety underpinning all the best practice. Workers should be empowered to stop work if they see a new hazard emerging, and training in hazard recognition should be provided for key workers. So companies that succeed in this can have incident-free decommissioning, basically through meticulous planning and rigorous training, and a culture that doesn't treat decommissioning as just basically this last thing we do, but is treats it as a high operational task requiring a high level of diligence. So as I said, global collaboration is happening, and the Centre for Decommissioning Australia is one of those taking part of this, and other best practices are helping to disseminate the information by talking about the alternatives to the high-risk endeavours such as robot intervention or standardized risk assessment tools, and developing better cutter technologies. So move on to the next slide. So the role of HAZID in enhancing safety and efficiency. So we want to go out there, we want to prevent the accidents. The primary benefit of a rigorous HAZID is, of course, to protect lives and the environment. So each case study we've examined, better HAZID could have helped them identify the hazard and understand how better to mitigate it. For example, the one where it had a falling skirt pile, or the opening deck, we could have saved lives by identifying the unknown hazard in that. So what's the cost of failure? Well, the cost of failure we've talked about is that we could have longer work stops for investigation, and also we'll face fines. Also, other projects have been halted for weeks because of safety breaches. So in a sense, having the issues up front with a hazard can identify everything and help us to understand what would delay and what, basically understanding what's happening first. Okay, and also we overcome operational efficiencies. Through a HAZOP, we improve project's efficiency. By foreseeing the problem, we can basically avoid it mostly. For example, recognizing the crane lift might cause rotation, and adjusting the plan in advance, we could prevent this loss, basically, and we're similar with other projects. So what's the future outlook? So the future outlook is ways of decommissioning are coming, and we need technological innovation to help overcome them. So we're going to see stricter oversight and also collaboration. Regulators are likely to tighten regulations for decommissioning safety. We're likely to see more explicit regulations opposed to just general rules. At the same time, regulators are going to collaborate more internationally. They're going to share more data. So that will be a good thing for us to understand. So there'll be an increased emphasis on planning decommissioning early. For example, regulators expect companies to have detailed decommissioning plans, included hazard assessments, and there'll be joint industry initiatives. So also environment and social responsibilities. The future of decommissioning will be shaped by environmental imperatives. So beyond the safety of workers, we'll have key aspects will be minimizing oil and gas spills as well. And they'll be looking forward for alternative decommissioning strategies as well. So the industry will need to engage stakeholders, the government, communities, and also NGOs to find solutions that are safe and more sustainable. So we're looking forward for more, and HAZID is only one part of this. So this is more holistic management kind of risk analysis. So ultimate trend is basically looking at everything as a whole as decommissioning, integrating safety, environment, and also long-term monitoring. But HAZID will always be a core part of this. So the goal is to decommission, leave a positive legacy, asset retirement with no unheard or no uncontrolled pollution, no lingering hazard for future generations. Move to the next slide. So just some more conclusions is that recap, real world accidents and near misses I basically have to underscore it's not business as usual. We're carrying out high risk consequence operations, and failure to identify the hazards have led to lives lost and also close calls with environmental issues. So basically, when hazards are recognized and mitigated, even challenging tasks can be executed safely. Every case study we review reinforces the mantra that basically identification of the hazards or hazards will be identified themselves and often painfully. So that's true. If we identify the hazards, we'll be able to mitigate them and put the safeguards in. And if we don't, they'll often, with a certain frequency, of course, identify themselves. So the role of a hazard is a robust process and is a cornerstone of preventing decommissioning incidents. And it's basically through collaboration and constant updates by adopting the question attitude, what could go wrong here? And not just putting it as a process, but learning from past incidents that we can foresee what would happen. So basically, we need to understand the incidents through hazards, and understand it's not just a one-off paperwork exercise, but a mindset of proactive vigilance throughout the entire project. I think this is the last slide. So what's safety and beyond? Well, often companies talk about the zero harm or zero thing. So that's a goal, zero harm in decommissioning, no injuries, no fatalities, no uncontrolled pollution. So if including this will require more, it's going to be more regulation, but general commitment to safety. So time, money, and sometimes commercial pressures can be in the way, but we need to have the hazard to, in a sense, understand the issues and move forward. So always plan with a worst case scenario in mind, embrace new technology and ideas to reduce risk, training the next generation of engineers in decommissioning practices, and fostering a culture where anybody can raise a safety concern. So final thought, decommissioning represents the final act in the life cycle of an offshore asset. By approaching it with the same rigor we did for all the other steps, we can basically understand that we can mitigate the tragedies, and instead of the story ending on a bad note, we can have basically leading forward to a clean, safe decommissioning by identifying the hazards and controlling them. So basically the issue is never stop learning. So thank you for everybody for listening to that.
So lots of interesting stuff there, lots of interesting examples, Martin. I think just to get things going, I had one or two things that I was interested in. I think firstly, if you think about, you talked about HAZID as a tool and a real process. Um, how do you think that, how has that approach changed through time, or has it changed through time? What are we doing now that we didn't used to do? What should we be doing now that we haven't done? What are
Mm,
the key trends in terms of how we actually practice this?
okay, so that's actually quite a good question. Some of the key trends is that they're getting more detailed, and whether this is good or bad, they're getting more into the risk ranking, where there's a lot more risk ranking involved, and it's a lot more detailed in that aspect. So we see hazards where the risk rank before and after safeguards. And that's a good way, but sometimes just getting the actual core safeguards in and the people in the room is actually better. And sometimes I think we could split it up into different sessions where you have different expertise. Also, other key trends we're seeing is that we're getting a lot more workforce involvement, and we're seeing it a lot more people coming in from the shop floor. You could say, I don't mean that in basically people that are maybe not used to the process coming in. So my preferred method is that, you know, we basically have everybody there committed to actually looking at what's happening and gaining an understanding. So I think there's been a trend where some things are getting better, also a trend where commercial makes some things get worse. But I think it's different companies, good and bad, over a whole range of things. Hope that answers that question.
Yeah, just to follow up on that, we've talked about the hazard as a very strongly technical process, and people often think about it of the technical teams working closely together, and we talk about integrated teams and as much diversity of individuals as possible involved. Specifically, though, what do you think is the role of leadership in this process? What should they be doing?
Yeah, this is sorry, another good question. So I think a leadership clear kind of setting out the safety culture. Uh, Maybe sometime, and this is a hard one for leadership, maybe sometime deflecting some of the commercial interests from the actual hazard identification by giving the people a kind of a more open remit to basically discover the hazards and to increase their kind of remit a bit so that they can actually explore what could go wrong, especially if they're uncertain about the operation. If this is new, as often decommissioning is, and it's uncertain what's happening, to let people maybe mull over it for a while to get all the hazards out. So let there to be a bit more of a kind of exploratory process. I also think one of the key things is the actual communication of the risks. So we get the risk register and it sits there and it goes nowhere. And the guys who are actually doing the job never see it or never get involved, and they're not aware of some of the risks. So this is because I've been offshore a lot and I've seen some of the operations, but I've never, seen a hazard through to offshore environment. It'd be interesting to see how that gets communicated. So maybe the operators to be more involved. I'd love to see people knowing exactly what's going on and it really getting to those job safety things. So no one's coming into the job site and maybe a shift changeover and they're not aware of what the hazards are. They're not aware of what they're doing. They're just doing what they're doing. And they think it's a normal operation. And then suddenly they find themselves in a situation like we said with that where the floor was opening because they didn't understand that and they just dropped through it. So they're aware of the hazards. So I think leadership needs to communicate, needs to ensure there's proper communication from things.
One of the things we talked about is the importance of activating the lessons learned from these incidents and these case studies into future hazard operations. So how do companies most effectively do that? And we talked about some platforms in which these lessons learned are captured.
Mhm.
But how do you go from that to actually incorporating it into the HAZID?
Okay, so that's interesting. Is that ways I've seen that is by sometimes at the start of the hazard or hazard sessions, so I'll extend it to that. There'll be a lessons learned. So sometimes the contracting company or the consultant will go away and review lessons learned and apply specific lessons from that. Also, we find that people with experts with knowledge from the area coming in and giving those lessons learned are important as well. And sometimes there's even some documentations, there's a requirement that the terms of reference has a structured lessons learned that they've learned from other things. So that's one way of key information going forward.
Thanks, Martin. Thank you so much, Barry, for dropping that in. So Barry has said this challenge of site-specific JSAs and understanding the working area and requirements, for example, the open hole in the deck, is not that different than many of the other work challenges we have every day. Is this specific to decom, or is it part of a broader lessons learned activity?
I suppose one of my points, and I mean, it's a fair question from Barry, that is that a lot of similar activities happen with similar things that are happening, and that's a fair point and fair. But I think what I've been trying to say is that sometimes it's the unexpected in decommissioning that can get us. And I think we can say that often with the experienced people and expertise in the room, we can get maybe 90% of the way there, but it's always getting the last few percentage, and sometimes maybe just spending a bit of time doing a hazard or getting an understanding of something that we may not have done before. So with some things with decommissioning we may have done before, but there may, as some of the examples, there may be some things like that North, I think it was the mono rig, may be unexpected. So that's why just some emphasizing an importance on actual looking at hazard with decommissioning and just maybe taking a step back as well. Hope that answered that one.
Thanks, Mark. We've had another question come in. Jing Xiao asks, may I ask, during offshore removal and transportation stage, are there incidents or near misses related to hazmat spillage? And particularly in the Australian context, what type of critical hazmat, LSA or mercury, is normally observed? So really, hazardous materials, spillage, what record of incidents do we see, and what are the controls around that?
Sure. Okay, I know of general hazards that I've done in that where they talk about the storage and the proper storage, but I don't have myself off the top of my head anything during transport that I could quote. Maybe if we look up some things, we can email an answer to that person who asked that question, and that could give them. But I've got no specific case studies I've got off the top of my head. If I don't want to waffle, so we maybe answer that one later.
Thanks. I think, again, going back to the sort of decom specific piece, you talked about one of the key issues with decom being around, the thing that kind of sets it apart is the structural integrity overprint. And, so what sort of controls do you typically see being brought into play there to help people address the hazards associated with the unknown or expected to be poor structural integrity?
That's a good question. I keep saying that's a good question because the simple answer is, how do we know what is unknown except from previous examples? So when we go through normal operation work, and we're doing this every day, the hazards, you could say most of the hazards are known. And I think because we're especially in Australia, the start of this, the reason, what we're trying to say here is that we just can go on past case studies that we have. And as people get more expertise in this area, we're going to build up a bigger kind of case study, a bigger kind of database that we can draw upon in hazard. And it's really getting those expertise. So the normal controls is, it's just really trying to understand the engineering going on behind it. So it's just like any hazard, is that really the only thing you have is getting the people in the room with a proper expertise and proper motivation to work out all the expertise. So I'm really saying is that the unknown is what we have to know, and that can only be done by good engineering, good expertise, and also just getting instance from the past that we can. Because if this is a one-time, first-time operation for the company and involved, and nothing like this has ever happened, we just need to draw upon that. We can't often predict the unexpected, but we have to engineer much of it out as possible. So sometimes often really taking time to listen to people about that.
We've got a question here, both for yourself and myself, actually. It says, are we aware of any centralized open databases for decom or subsea focused LLs stroke instance accessible for asset owners or contractors? It's interesting because we talk to our counterparts in the UK, Decommission, who I know are working with their local safety, industry area around this, but I'm not even sure if they have yet built that up. But I know I don't know of any specifically focused decom instant or safety database here. I don't know if you know of anything else, Martin.
Nothing that's just everything that's in a one central place. I mean, I'm hoping that regulators will move forward to have sharing of data, and I suppose that's a good role for organizations to get involved in, to push for.
The only thing is I had to sort of build off some of the questions I've already asked around, what sets decom apart in this space, and how do we build a good understanding of the key controls which are unique to decom, or is that, or am I fundamentally looking at it the wrong way in that space? Am I assuming that should be the case, whereas in fact we should sort of view it more as a sort of continuum of operations and try and link and learn more proactively?
Good question, isn't it? I think there should be an acknowledgement that this is unusual, but it shouldn't be. You shouldn't throw out let's say, the baby with the bathwater. You shouldn't throw out everything that you've done in the past, the safe way of operation, just because you go to a new phase of operations. But you should be innovating as well. I think maybe in the future, the whole of the industry is going to see a lot of innovation coming through the use of AI for helping to identify risks, and also robotic operations, but that's a bit more pie in the sky view, the kind of idea we're talking about the next 20 years. So hopefully there'll be a lot more kind of people that are around that have information, like lessons learned that we can get from big databases from what you've talked about. So I think it's going to be a mixture of both.
Yeah, do you see operators being more understanding of the potential cost impact, or allowing contract flexibility required with unknown asset condition during decommissioning, noting UK is more advanced in this field compared to Australia? So do you see operators being more understanding of the potential cost impact, or allowing contract flexibility required with unknown asset condition?
From a safety engineering point of view, I certainly hope so, because being commercially, I'm commercially aware that decommissioning obviously is a cost at the end of the asset. But from a safety point of view, I certainly hope so. I'm hoping the regulator, this is just a personal opinion, I'm hoping the regulator certainly helps companies realize this, that it's not just something that you have to do, we need to do it safely. But the future is the future, unfortunately, and it's kind of beyond my control. I think forums like this, where we're advocating things and trying to get the message, and the stakeholders involved, are important steps to that.
Yeah, in fact, Richard, I've just seen the other version of your question on the other page, and it was talking specifically around contracting styles and the openness of operators to things around EPCI or lump sum and all that sort of thing. How does, you know, consideration of the asset condition actually play into that? Or do you think it does at the moment?
Okay, just from my point of view, is I presume you want me to answer this rather because you guys probably could answer this as well from CODA. But from my point of view, I have gone into projects, and it's not always in decommissioning, and it's in any project, and the actual contractual way it's set up can really hamper the safety and the hazard and the contracting. And I'm not an expert in the contractual way of it. I'm an expert in the safety, but from observing from a safety professional point of view, is that contracts can be the bane. They can really make it hard for communication between companies and how things are being setting up. And if the company and the contractor and the consultants are in silos, it can really be hard. So I'm not going to advise any way of doing it, but I acknowledge that this is a problem. And there needs to be work around this and needs to be implemented. I think it's going to be a big issue going forward.
Thanks for providing some feedback on that one. It's always interesting. It's been a very interesting conversation, and we've touched on a quite wide range of potential incidents and things that we've learned from in the past. And if there's nothing else, it remains for me to sincerely thank Martin Bardsley and everybody at Vanguard Solutions for standing up this session for us today. Very much appreciated your openness and insights, and to thank all of you for joining us again and for your questions and probing. It's really good conversation, and we really appreciate your engagement. Thank you very much indeed, folks. That's going to be the end of our session.
Thank you very much.